Alright, we are doing lesson 5.3 here, trig expressions. This is also the last one for unit 5. Topics for this one. Again, please have this handy with you all the time to be able to refer to it. So the first topic for this one is find 4 trig ratios given sine theta and cosine theta. Slightly different from 5.2, but not too different. So for example, if I'm already given sine and cosine, am I able to figure out the other 4 trig functions? The example could be, let's say sine theta is given to us and is equal to -3/5. Cosine theta is equivalent to 4/5. And my job here is to find the other 4. And I've done this before several times. Sine theta, cosine theta, and tangent theta. Make sure you keep them in the same order. And then we put cosecant theta here because cosecant and sine are inverses of each other. We put secant theta here because secant and cosecant are inverses of each other. And cotangent theta here because cotangent and tangent are inverses of each other. Sine theta is equivalent to the y-coordinate, x-coordinate, y over x over y, 1 over x, and 1 over y. These are the formulas. Alright, but I do not know the x and the y coordinates. However, we do know from unit circle that cosine theta is the x-coordinate and sine theta is the y-coordinate. So if I were to put this together, the coordinate is 4/5, -3/5. And now, actually, I have it. This is given, this is given. Tangent is y over x. So you take the y-coordinate and put it over x. And thankfully, as you can see, the denominators are both the same and they can go ahead and cancel out, leaving me with -3/4. Cosecant is inverse of sine. Since I already have sine, I just have to conveniently find the reciprocal of that. This one had a negative, so keep that negative in the answer as well. This is 1 over x, so if I flip over cosine, I get secant, and cotangent is x over y. Since I already have tangent, I'm going to flip it over, and I have my other 4 as well. So these two were already given to me, and those two actually gave me the point. From there, I just had to follow the formulas. Now I have all 6 of them, and I have completed my 6 trig ratios. Alright, let me give you another example, because when radicals are introduced, then it can somehow get challenging. Actually, this one is from Math Excel. This is a homework question as well. Sine theta is given to be 1/7. Cosine theta is given to be -4√3/7. And I have to find all the other. Now I have 4 leftover trig ratios given sine and cosine. But first I need to recollect to myself that since they gave me sine and cosine, they actually gave me the coordinate points. Now that I have this put together, I should be able to construct my table in that same order as I said earlier. Cotangent, this is given, this is equivalent to y, and hence sine theta is 1/7. This is equivalent to x, hence cosine theta is -4√3/7. This one's going to be interesting. We have y over x, -4√3/7. Thankfully, these two cancel. Don't forget there's a negative here, so the negative will stay in my answer, and we are down to 4√3. Now this is not simplified all the way because of the radical in the denominator. So on this side, I'm going to take care of the radical. Watch this one carefully. I'm going to multiply by, rationalize it. That gives me -√3. Now root 3 times root 3 is 3, but don't forget there is a 4 we have to multiply with as well. So 4 times 3 is 12. And this ends up being negative root 3 over 12. And that's acceptable because there are no radicals in the denominator. This one should be easy peasy. It's 1 over y. So flip over your other answer, 7. This one flipped over will be 7. Don't forget the negative for root 3. But again, this is not acceptable. So I'll have to take care of the radical by rationalizing it. Negative stays, 7 root 3. Root 3 times root 3 is 3. And don't forget there's a 4 there. So 4 times 3 is 12. And cotangent will be flip over of this. I'm going to take the previous answer and flip it over. And I have taken care of all 6 trig functions for that particular point, which in fact was given in the form of sine and cosine. All right. All right, second topic is being able to find trig expressions using unit circle. So we're going to do these. Well, again, watch these ones carefully. They're like little puzzle pieces. They're kind of interesting if we know what to do with them. Let me actually try and do it on the side here. So keep the unit circle handy. So second topic is, am I able to evaluate trig expressions? Let's start with a very basic one. Oh, before I even start, let's read, make sure that we understand this. Let's say I pick 150 degrees. So there are 5 things that are associated with 150 degrees. This is the degree value of the angle, because that point, if I were to connect this point with the origin and then connect this here, this angle is 150 degree angle, right? That's why that point is 150 degrees. Okay, the next thing here is the radian equivalent of 150 degrees. If 150 degrees was converted into radians, we would multiply it by pi over 180, like how we learned in the class. Zeros cancel, 3 goes into 15 5 times, 3 goes into 18 6 times, and hence this is 5 pi over 6. That's why it's 5 pi over 6. And you can convert each and every one of them, or use the unit circle where the conversions are done for you. Then comes in the point, the x-coordinate and the y-coordinate. The x-coordinate is always cosine of that angle. Y-coordinate is the sine value of that angle. And the last one, which is given in green, is the tangent value of that particular angle. Okay, so a lot of information is given here. If I were to pick something else, the same situation, if I were to pick this, right, we have the degree equivalent, 315. The radian equivalent of that is 7 pi over 4. Cosine of 315 is root 2 over 2. Sine of 315 is negative root 2 over 2. And tangent of 315 is negative 1. So pretty cool information there. Let's just use this now to evaluate a few things. Let's start with simple. Cosine of 45. So go ahead and locate 45 right there. And as I said, cosine is the x-coordinate. So root 2 over 2. And we are done with that. Let's say we have sine of 7 pi over 4. First, I need to locate that angle. 7 pi over 4 is right here, right? Sine is the y-coordinate, so be sure to pick the y-coordinate, not any other. Root 2 over 2, done. Something simpler, let's say tangent of 0 degrees. So all the zeros are right here, conveniently located, right? 0, 0, 1, 0, 1, 0. Tangent, as I said, is the outside one. Also, there's a key listed right here. If you stick to this particular unit circle, tangent is the one in green. Okay, so tangent of 0 is 0. Okay, now what if instead of these 3, the other 3 are given? Let's say we have cosecant of 5 pi over 3. So now pause and wait. First of all, is cosecant given on unit circle? Unit circle has these 3. Okay, it does not have cosecant, it does not have secant, and it does not have cotangent. right? However, since these three are inverses of, this is inverse of sine, this is inverse of cosine, and cotangent is inverse of tangent, those three are on unit circle. So we will first find any of the given ones and then find the reciprocal to get to these three. Now this one's asking me cosecant, and hence cosecant is paired with sine, and hence I have to find sine first and then find the reciprocal of that to get to cosecant. So I have to find sine of 5 power 3. 5 power 3 is right here, and the sine is the y-coordinate. So I'm like, okay, that's negative 2 over root 3. If I were to reciprocal that, oh no, I this is, I didn't put it right. It's negative root 3 over 2. So to get to cosecant, I will have to flip it over, and that would be the cosecant, because this was my original question. And then I have a little problem I have to take care of by rationalizing the radical. And there we go. So cosecant of 5 pi over 3 is negative 2 root 3 over 3. We do not have to convert it to decimal. Let me write it one more time here. Sine is to cosecant, cosine is to secant, and tangent is to cotangent. Keep that in mind. If we were asked any three of these, we will first have to find their reciprocals, then get to them. Here's another example. Okay, let's say cotangent of 45. Again, register in your mind, cotangent belongs to one of these circles, so it's not directly on there. I will first find tangent of 45 and then reciprocal that. Let's go to 45. And tangent is the outside one in green. So this is 1. All I have to do is flip over 1. And reciprocal of 1 over 1 is 1 over 1. There we go. All right. Okay. Let's try cosecant of pi over 2. Again, register, cosecant, none of these are on there, so I have to first find sine. Let me find sine on the side or here, pi over 2. Then I get to pi over 2. Pi over 2 information is all in this bubble. And I'm looking for sine. Sine is the y-coordinate. So sine pi over 2 is 1. If I reciprocal that, that's still 1. So I found it. Okay, another example. Secant of pi over 6. And again, secant belongs to one of these. The secant is not on here. I have to first find cosine. So I'll first find cosine of pi over 6. Let's go ahead and find pi over 6, which is this bubble, because pi over 6 is right there. Cosine is the x-coordinate, so root 3 over 2. I'm like, this is root 3 over 2, hence secant will be 2 over root 3. And a quick fix to the radical. There we go, and I have found secant of pi over 6. How does it get any more complicated? When we start combining them. So for example, let's say I have sine of 45 plus cosine of 45. So now we're adding them. I have to individually find their values and then add them together. Sine 45. 45 is right here. Sine is the y-coordinate, so that's root 2 over 2. And cosine of 45, same position, but the x-coordinate, which is also root 2 over 2. Now, do I know how to add fractions? Well, they have the same denominator. So I can combine the denominator, and it's root 2 plus root 2, which is 2 root 2's, right? It's like 1 root 2 and 1 root 2 adds up to 2 root 2 over 2. 2 and 2 cancel, so this is just root 2. You can convert it to decimal, which is 1.414, but if this is not one of the answers, then you will have to stick to the radical answer. Okay, another example. Let's say we have secant of 30 degrees and cotangent of 45. Now wait and understand this. This one was addition. This one, because there's just no sign in between the two, it's automatically multiplication. Okay, keep that in mind. Just like let's say we have 2x. 2x basically means 2 times x, right? We just don't really write that operation. So let's go ahead and find secant of 30, then find cotangent of 45, and multiply them. So secant of 30. One more time, secant is in the bubble, so that means secant is not on unit circle. I have to first find cosine. So let me on the side find cosine of 30. Erase that. 30 is right here. Cosine is the x coordinate, so it's root 3 over 2. And hence, secant will be flipped over version of this. Got that? Now cotangent, whoopsies, again cotangent is the one that's not on unit circle. So I have to find tangent and then flip it over. Tangent of 45. 45 is this circle, so tangent is the one on the outside. That's a nice little 1. So if I flip it over, I still have 1. Okay, so this was on the side. Now I'm like, how do I add these two? You would want to pick up a calculator, but again, if they're not in decimals, we'll be stuck. I'm going to make the denominator same, so I'll multiply this by root 3 times root 3. Now the denominator is the same. And that is the answer right there. You can pick up a calculator, find the decimal equivalent of that. But if it's not in the answer choice, then we'll have to stick with the radical form of the answer. And more examples where we are solving expressions. Let me give you something that involves subtraction, because you didn't do subtraction. Minus cosine of pi over 2. Okay, cosine I know is on unit circle, so that's good. Cosecant is not. And to find cosecant, again, I have to find sine first. On the side, I'm going to find sine of pi over 2. Sine of pi over 2. Pi over 2 is right here. Sine is the y coordinate, so it's 1. And 1s are easy to flip. So if I flip this, it's still a 1. Beautiful. Minus, now cosine of pi over 2. Cosine is the x coordinate, and I'm still on pi over 2, so I didn't have to change location. That was 0, I believe. 1 minus 0. Simple, easy peasy. That is 1. And I have solved this as well. Now it's just a matter of more and more examples and practice. And this comes with practice. Boom, 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 boom. Oh yeah. Okay, my last two examples. 2 sine pi over 4 plus 3 tangent pi over 4. The way you want to read this is, this is kind of like 2x plus 3y type of deal. 2x plus 3y. Where x is a trig expression and y is also a trig expression. 2 is 2. 2 is not going to change. I want to find value of this, and that's what will go here. Plus 3 times the value of that, which will go here. Okay? That's how you want to read it. It's 2 times the value of that plus 3 times the value of tangent pi over 4. Now, thankfully, sine and tangent are both on unit circle. I just have to get to pi over 4 and get sine value and tangent value from there. Pi over 4, right there. Sine value is the y coordinate, and tangent value is the one on the outside. So root 2 over 2 and 1. So this is root 2 over 2, and this is just a 1. Awesome. Now this follow PEMDAS. We'll have to multiply first. Can't do the addition part. We have to multiply first. 2 and 2 cancel. So we have root 2 plus, if we multiply these two, which is just a 3. And boom, answer is done right there. You can pick up your calculator, as I said earlier, get a decimal value for that, which will turn out to be 4.414-ish, I believe. And if the answers are given in decimal, awesome. If the answers are not given in decimals, then it's going to look like this box. All right, and the last example. Let's say we have 8 secant pi over 6 plus 7 cotangent pi over 3. How do you want to read this? This is 8 times the value of that plus 7 times the value of this. So 8 times something plus 7 times something. Okay. Secant pi over 6. Secant is not on unit circle, so I'll have to find cosine first. Cosine of pi over 6. Pi over 6 is right there. And cosine, so this is all of it. And cosine is the x-coordinate. So root 3 over 2. Oh no, I forgot to flip it. That's the value of cosine, root 3 over 2. But I want secant, so I have to flip my answer. There. Now for cotangent, I have to first find tangent of pi over 3. Let's go to pi over 3. There it is. And the tangent of that is this nice little root 3. So I come here, well, this is root 3. So cotangent will be flipped version of that. Okay, once I got their values, again, follow PEMDAS. I have to multiply these two first. 8 is basically 8 over 1, so it's 16 over root 3 plus 7 over root 3. And root 3 can be combined because it's the same denominator. 16 plus 7 is 23, and there's my answer, but have to rationalize it because of the denominator being a radical. And there we go. So what was it? 8 times secant pi over 6 plus 7 times cotangent of pi over 3 is 23 root 3 over 3. Okay, that's a lot of examples, but we basically covered 2 topics. Our first topic was building up on what we did last time. If we are given sine and cosine, can we figure out the other 4 trig ratios? This was math Excel problem. If we are given sine and cosine, can we figure out all other 4 missing ones? Okay, and I gave you 2 examples there. And then we learned how to find values of trig expressions and trig values in general using our handy dandy unit circle. All right, this wraps up 5.3 for us for now. I will see ya